All right, buckle up, everybody, because today we are diving deep, deep into the fascinating world of mechanoluminescence.
Mechanoluminescence.
Yeah, like when you crack a lifesaver mic in the dark and you see that little spark of light,
Oh, right, yeah.
that's mechanoluminescence. It's basically light that's generated by mechanical stress.
Wow, that's pretty cool.
I know. And after this deep dive, trust me, you'll be the life of the party, dropping this knowledge on everyone.
Huh,
So we've got a bunch of research and articles here, and I'm really excited to kind of unpack all of this.
me too.
But first things first, what exactly is mechaniluminescence? Can you break that down for us?
Well, to put it simply, it's when materials emit light when they're under mechanical stress.
So like when they're being pushed or pulled or bent.
Exactly. Even cracked, like that lifesaver example you mentioned.
Right, right. So the candy's being stressed as it breaks, and then boom, light.
Exactly. And what's really amazing is that scientists can actually measure this light to figure out exactly how much stress a material is under.
Woof. So it's like the material's talking to us, saying, hey, I'm feeling the pressure here.
Yeah, kinda.
That's wild. So it's not just a neat visual effect. It actually has some serious scientific applications.
Oh, absolutely. The potential applications are huge.
That's what I'm excited to talk about.
You could have, for example, bridges that glow brighter as the stress on them increases.
Whoa, wait, hold on. So you're saying like a bridge could basically warn us that it's about to have a problem.
Exactly. It'd be like an early warning system for structural problems.
That's incredible. But is it all just one kind of light, or are there like different ways this mecholuminescence thing can happen?
That's a great question, and it kind of leads us to another fascinating aspect of mecholuminescence.
Okay, lay it on me.
It's not just one single phenomenon, it's more like an umbrella term. Yeah, it covers a whole bunch of ways that materials can emit light in response to motion or mechanical stress.
Oh, I see.
It's like, think of it like the word fruit, right?
Okay.
You've got apples, oranges, bananas. They're all different, but they're all fruits.
Right, I get it. So we've got like this whole fruit basket of mechanoluminescent fruits, so to speak.
Exactly.
What's a really juicy example of this?
Well, have you ever seen those videos of like glowing waves in the ocean?
Oh yeah, those are amazing.
That's a form of mechanoluminescence.
Really?
It's called bioluminescence, and it's exhibited by some marine organisms.
So like little tiny creatures in the water are glowing.
Yeah, they emit light when they're disturbed by, the waves or a passing boat.
That's so cool. But how does that tie back to the stress sensing idea? Those creatures aren't exactly cracking under pressure, are they?
It's definitely a different mechanism, but it still falls under that big umbrella of mechanoluminescence. In this case, the mechanical stimulation of the water is what triggers a chemical reaction within these organisms, and that results in the light emission.
So it's like they have their own little built-in light show activated by movement.
Exactly.
That's really neat.
It is, and it just highlights the incredible diversity of mecholuminescent phenomena.
Right.
But going back to your question about stress sensors, imagine painting a bridge with a special coating that glows brighter as the stress increases.
Oh yeah, you were talking about that earlier.
We could literally see potential problems before they even become catastrophic.
Okay, I'm starting to see the potential here. We're talking about like early damage detection in a way that we never could have imagined before.
Exactly. And this concept isn't limited to bridges. It could be airplanes, buildings.
Wait, even my phone screen could tell me it's about to crack before it actually happens?
It's definitely within the realm of possibility. By incorporating these mecholuminescent materials into everyday objects, we could have like a built-in early warning system for all kinds of damage.
That's incredible. But how does it actually work? Is it just that the material itself glows, or is there some kind of process involved?
Well, at its core, mecholuminescence is all about energy conversion.
Energy conversion.
Yeah, we're talking about taking mechanical energy, that force of stress or motion, and transforming it into light energy.
So it's like a mini power plant. But instead of generating electricity, it's generating light.
That's a great way to put it.
Cool.
And it raises a really interesting question. Could we harness this energy conversion for other purposes?
Like what?
Well, what if we could create self-powered lights that are activated by motion?
Oh, wow.
Imagine your shoes lighting up as you walk, or your jacket glowing in the dark.
Now that is a conversation starter.
Exactly. The possibilities really are endless, and it all stems from this fascinating phenomenon of mecholuminescence.
Light from mechanical energy. Who knew?
Right. It's really amazing, right? You start thinking like, if we can turn motion into light, what other kinds of energy conversions could be possible?
I know, right? And we've been talking about bridges and phone screens and all that, but I mean, this could have implications for so many different fields.
Absolutely. And we've only just touched on how this technology could be used to, detect damage. What if we could actually use it to prevent damage from happening in the first place?
Prevent damage. How?
Self-healing materials.
Self-healing materials. What is this? Science fiction.
I assure you it's very real, and it's closely tied to the principles of mechanoluminescence. Imagine a material that not only, detects a crack forming, but then actually, automatically repairs itself.
Wait, so the material could heal itself. How is that even possible?
Well, scientists are designing materials at the molecular level to have these incredible properties. So, for example, you could create a polymer that contains tiny capsules filled with a healing agent.
So like little first aid kits embedded in the material.
Exactly. And when a crack forms, right, and that mechanoluminescent material glows, it could trigger a reaction that actually ruptures those capsules, releasing the healing agent, and then it flows into the crack and seals it up.
That's mind-blowing. It's like we're giving materials their own superpowers, the ability to regenerate.
Exactly. And what's really exciting is that, researchers are now combining these principles of mechanoluminescence with these self-healing materials.
Oh, wow.
So you could have a bridge, right, that not only alerts engineers to potential cracks, but then actually automatically repairs those cracks.
So no more, catastrophic bridge collapses.
Potentially, yeah.
That sounds like something straight out of a movie, but you're telling me this is actually like a real possibility.
The research is still in its early stages, but the potential is enormous. I mean, we're talking about a future where materials are not only stronger and more durable, but they're also smarter, they're more responsive, and it's all thanks to this amazing phenomenon of mecholuminescence.
Okay, I'm officially hooked on this topic, but I have to ask, are there any downsides? I mean, this all sounds a little too good to be true.
Well, like with any new technology, there are challenges.
Of course.
And one of the biggest challenges is efficiency.
Efficiency.
Yeah, right now, a lot of these mecholuminescent materials aren't very efficient at converting, that mechanical energy into light energy.
So you're saying the glow is like kind of faint?
In many cases, yes, and this obviously limits the practical applications, right?
Sure.
But researchers are working really hard to develop new materials that have, higher efficiency, so brighter glows are definitely on the horizon.
Okay, that makes sense. Are there any other challenges that they're facing?
Durability is a big one.
Durability.
Yeah, a lot of these mecholuminescent materials, they're brittle. They can break down easily under repeated stress.
Oh, okay.
So researchers are experimenting with different materials and different fabrication techniques to try and create, something more robust, something that will last longer.
So we need materials that can take a beating but still glow brightly.
Exactly. And finally, there's the challenge of scalability.
Scalability.
Yeah, a lot of the most promising materials are actually really difficult to produce on a large scale. So, it's all well and good about these amazing discoveries in the lab, but, how do we take that and make it work in the real world?
Right, that makes sense. So it sounds like we have a few hurdles to overcome, but it also sounds like researchers are making progress. So what are some of the most exciting areas of research right now? Where do we go from here?
Well, one area that's really taking off is energy harvesting.
Energy harvesting.
Yeah, imagine, harnessing the power of human motion to charge your devices.
Hold on, are you saying we could charge our phones just by walking?
That's the idea. Researchers are actually developing mechanoluminescent materials that can convert mechanical energy from things like footsteps or even, the beating of your heart into electrical energy.
So you're saying our bodies could become like walk-up power plants?
In a way, yes.
That's incredible. But how would this energy harvesting actually work? Would we have to wear special shoes or?
It's all about incorporating these materials into everyday objects. So, for example, you could have a sidewalk made of tiles that generate electricity with every footstep.
Wow. So you're saying we could power entire cities just by walking around?
Well, it's definitely a bold idea, and there are challenges. We're not talking about, powering entire cities just yet, but for smaller applications like charging your phone as you walk, it's definitely within the realm of possibility.
That's fascinating. Makes you wonder what other, everyday activities we could be using as energy sources. What about using our heartbeat to power a pacemaker?
Now you're thinking outside the box. That's exactly the kind of innovative thinking that's driving this field forward.
This is all so incredibly exciting. It feels like we're right on the verge of a major breakthrough. But let's shift gears for a moment and talk about another really exciting area of research, biomedical engineering. How is mechanoluminescence being used to, improve human health?
Oh, there are so many possibilities in this area. For example, researchers are developing mechanoluminescent sensors that can be implanted in the body.
Implanted.
Yeah, to monitor things like blood pressure or even bone healing.
So instead of relying on like bulky external sensors, we could have like these tiny little glowing sensors inside our bodies.
Exactly. And these sensors would be biocompatible so they wouldn't, cause any harm and they could provide real-time feedback on a patient's health without the need for, any invasive procedures.
That's amazing. It's like having like a built-in health tractor that's constantly monitoring your vital signs.
Right.
And since they're powered by microluminescence, they could potentially last for years without needing a battery replacement.
You got it. And that's just the beginning. I mean, researchers are also exploring the use of mecholuminescence in drug delivery
Hold
systems.
on, glowing drugs. Now that's something I have to hear more about.
Imagine tiny nanoparticles, right, filled with medication.
Okay?
And these nanoparticles would be coated with a mecholuminescent material that would only release the drug when it's subjected to a specific type of mechanical stimulation,
Like what?
like ultrasound waves, for example.
So you're saying we could target drug delivery to very specific areas of the body using sound waves?
Exactly, and this would allow for, much more targeted and effective treatments with fewer side effects.
Wow. I can't believe how far-reaching the applications of this technology are. We've talked about everything from self-healing bridges to glowing drug delivery systems. It's truly mind-boggling. But I have one final question for you before we move on.
Sure, go ahead.
We've talked about all these amazing potential applications, but what does this actually mean for the average person? How will this impact our lives in the years to come?
That's a great question, and I truly believe that mecholuminescence is going to have a profound impact on our daily lives.
Really?
Oh yeah, in ways that we can only just begin to imagine. It's going to change the way we interact with our environment, the way we power our devices, and even the way we think about health and safety.
So you're saying this isn't just like some abstract scientific concept, but something that's actually going to have, real-world implications for all of us.
Absolutely. Mechanoluminescence it's poised to become an integral part of our lives, much like, electricity or the internet.
It's incredible to think that something as simple as, cracking a lifesaver mint in the dark could unlock such groundbreaking technology.
It just goes to show that there's still so much wonder left to discover in the world around us.
Well, I, for one, am excited to see what the future holds for mechanoluminescence. I'm sure our listeners are too. It's been a fascinating conversation. I've learned so much. Welcome back to the Deep Dive. We've been on this incredible journey exploring the world of mechanoluminescence, everything from glowing sea creatures to self-healing materials.
Even glowing drug delivery systems, it's pretty wild stuff.
Yeah, and we talked about some of the challenges that researchers are facing, like improving the efficiency and the durability of these materials, and even just figuring out how to produce them on a large scale.
Right, those are big hurdles, but I think it's clear that this technology, mechanoluminescence, has the potential to revolutionize so many fields.
Oh, absolutely. I mean, we're talking energy harvesting, biomedicine, and who knows what else is out there.
Yeah, the possibilities are endless. And I think the most exciting part is that we're really just, at the very beginning of this journey.
It's true, yeah.
As researchers continue to kind of unlock the secrets of mecholuminescence, I think we can expect to see even more innovative and mind-blowing applications emerge.
Okay, so now I got to ask, what kind of future applications are we talking about? Give me some more of those mind-blowing possibilities.
Well, one area that I think has immense potential is flexible electronics.
Flexible electronics.
Yeah, imagine like foldable phones or wearable devices that are powered by your own movements.
So we're talking electronics that are not only flexible but also self-powered.
Exactly. These mecholuminescent materials could be, integrated into these devices to provide both energy and illumination.
Wow.
Imagine like a smartwatch that charges as you move, or even, clothing that lights up as you walk.
Okay, now that's a fashion statement I can get behind.
Right.
But beyond fashion, I mean, there are some serious safety applications here, right?
Oh, absolutely. Think about like safety gear that illuminates in the dark, so workers or cyclists are more visible to others.
Oh yeah.
You could potentially save lives with this technology.
That's a brilliant idea. What about using mecholuminescence in buildings or infrastructure?
Oh man, the possibilities there are really endless. Imagine buildings that glow when there's an intruder or bridges that change color to alert drivers of, potential hazards.
It's like giving these structures a sixth sense, the
Yeah,
ability to communicate with us.
exactly.
It's just amazing to think that something we've, often taken for granted, like a simple spark of light, could have such a profound impact on our world.
It really is, and it just highlights, the importance of scientific curiosity and the power of observation. Sometimes the most groundbreaking discoveries, they come from the most unexpected places.
That's so true. Well, you've definitely given me a lot to think about, and I'm sure our listeners are feeling just as inspired.
I hope so. It's been a real pleasure discussing this topic with you.
The pleasure was all mine. And to our listeners, if you want to see some truly amazing examples of mechanoluminescence in action, be sure to search for videos online. You won't be disappointed. Until next time, keep exploring the world around you and never stop asking questions.
That's right. That's the key to unlocking new knowledge and understanding. And who knows what other amazing discoveries are waiting just around the corner.
That's it for this deep dive. We'll see you next time for another deep dive into the fascinating world of science and technology.